Just as we jump away from the last video that focused on slope analysis, there's something else that I just thought I'd throw in here. One of those things is that using LiDAR information has actually given us a lot more detail just in our ability to have kind of high quality graphics coming out of the slope analysis process. The other thing is that you'll see here that stoplight analysis doesn't have to be kind of bold, bright stoplight colors, red, yellow, green. You can actually adjust those colors to any color that you think makes sense in your overall presentation. And then what I've done here is that I've actually taken the stoplight analysis and I've dropped it in over the top of my hillshade. And so one of the best tools that you're going to find for that is to actually go ahead and place the stoplight analysis over the top of your hillshade and then use the Photoshop menu that allows you to adjust from normal. We usually use multiply. In terms of the layer interaction effects, one of the things that I found is that color burn or color dodge sometimes tend to be the best for getting this information to display on top of one another. But ultimately, a lot of this information, as we start thinking about soils, is really trying to understand how does water move across the site. And so we've talked about this example, some work I've done down in New Orleans, of how we actually started looking at both wet storage and primary drainage and surface drainage across the site. It would have been great to have GIS to be able to inform this particular design. So what we're going to be doing here, I need to go ahead and adjust my screen just a little bit. Hopefully it'll let me, oops. Well, is that I'm going to show you a stormwater analysis process. And I actually need, let's see if I can pull that over just for a minute. I need you to see a slightly different part of my screen right now. So what we're going to be doing is we're going to be working with a set of tools underneath the hydrology toolbox. And so hydrology toolbox is underneath spatial analyst tools. And what these are going to allow us to do is it's going to allow us to actually step through a relatively routine procedural approach to studying stormwater flow within a site. This is a more advanced GIS skill set than I've actually ever introduced in 316 before, but it is so useful and so straightforward that I'm excited about being able to share this with you, especially here in Happy Hollow Park, where this is such a critical part of the overall process that we're experiencing. So I'm going to go ahead and shift this back. But what you're going to see is a series of steps that are all outlined in that, are all tools that are available within that spatial or in that hydrology toolbox. And the first one we're going to start with is we're going to start with DEM fill. And so let me go ahead and just jump over to my GIS here real quick and then go ahead and recenter that in that space. So what we need to do is, again, we're going to be working with our DEM. As I jump into the hydrology toolbox, the first thing I need to use is fill. What fill does is it actually corrects for small imperfections in the data. We wrapped up the last video talking about some of the problems that are likely hiding within that overall data set. It happens. It's a normal part of working with GIS data. But what I'm going to do in this particular case is I'm going to go ahead and input my DEM, and we're going to go ahead and perform a fix on it. So a fill on this. And so what I'm going to type in here, and then for me, this is stormwater analysis. And I'm going to actually just call it out by name and call it out as fill. All right. And hopefully that's a short enough name. It doesn't worry about it as it pulls it in. Looks like we're good to go. I'm going to run this, but this may take a few minutes. So I'm going to go ahead and stop the video before I do that. All right. So the process went ahead and finished. And what you're actually going to see doesn't look all that much different than the DEM we were working with a moment ago. Really, all it is it's a newly constructed DEM where some of the imperfections have been filled so that the data set is prepared to go ahead and run the next step in the process. So the next step in our process is that we're actually, so moving on from our DEM fill to fix the imperfections, we're going to move on to how does water flow. So flow direction is the next step in our process. So I'm going to go ahead and use the flow direction tool. And in this case, what I need to make sure I do is that instead of using the original DEM, I need to make sure that I bring in that filled layer. What it's going to do here is that, again, I'm going to call it HHP SA, and then I'm going to actually call it flow direction and hope that that doesn't kick me out for naming conventions. And it did, because it doesn't like anything over 8 characters. So let's try that. I'm close. Looks like we're good to go. All right, another decision we have to make is that do we want to force all edge cells to flow outward? And this is an interesting decision. In general, I would actually say no. We don't want to have all the edge cells flow outward, just because we have a square DEM here that really just represents where the data came from, and then it flows, opposite directions, which means that every cell on the outside flows out of this. I'm not going to check this in this particular case, even though I will in some, I have in other opportunities, because I know that most of the water is flowing down through this site. And so I'm not too worried about water flowing back uphill from the Wabash River in this particular instance, but I am concerned about forcing some things that definitely are flowing through Happy Hollow Park, forcing them away. So long story short, that's the reason I'm going to leave that unchecked, but largely put your raster in, you tell it where to save, and then you hit OK, and it's going to go ahead and calculate a flow direction for me. Again, this can be another lengthy calculation, so I'm going to go ahead and hit pause and resume here in a minute. I don't know how long that took for you, but in my case, it took about 5 minutes to go ahead and run that analysis. And again, so I'm going to go ahead and just close that. And let's go see what we found. I'm going to zoom to the overall layer. And what you're going to see is each of these colors represents part of this directional flow across the site. And so what I mean by that is if I go ahead and zoom in here, you can start to see how water is flowing into, in and through this site. And so probably the easiest way to visualize this layer is go ahead and leverage your hillshade and come in and turn this on so you can actually see how the water is flowing across the site, and you can actually see how detailed this analysis get. It really is giving us a strong indication of every step along the way. Our next step in the process, in addition to flow direction, is that we actually want GIS to give us a flow accumulation. More or less, I don't want to spend my time going into this data set and trying to decipher where water is going. I want GIS to do this for me. And the tool that we use this is called flow accumulation. It's also called, generally referenced as stream order classification, meaning that what it's trying to do is that it's effectively creating a network of surface water flows in a storm event, and where those water flows are going to come together is going to look like a stream network. Now, recognize that not all of these are actually streams, right? These are just happen to be locations on the landscape where, because of the elevation change and because of existing topography based on how water flows downhill, this is where water comes together. Again, incredibly useful for us as landscape architects to have this ability, have the ability to jump right into this analysis. And so I'm going to go ahead and do that in this particular case, and go ahead and pull up flow accumulation. I'm going to bring in, it asks for input your flow direction raster. In this case, I just do the same thing that I've done every time, which is Happy Hollow Park, stormwater analysis, and then I'm going to just call this out as flow accumulation. And let's see if that's too long of a name. Looks like I'm good to go. Again, there are ways to go ahead and make some other manipulations. I can change out some of these. All of this is available to you over here in the help menu or help window. You can also click on the tool help. It will take you to more resources to read about these. At this stage of your development in GIS, though, I generally want you to go ahead and just use the defaults, right? They're default for a reason. It generally means that they're going to work out for you. Let's see what this goes ahead and produces. Again, I expect this to take about another 5 minutes. All right, so that took a number of minutes to go ahead and bring that together. And what I ended up getting on the far side of this is I got largely reported out as more or less a black layer. Problem with that is that's not actually accurate, and you can start to see it if you zoom in the right places, that you'll actually see some fading white lines that really are being hidden out here by my parcel information. And so I'm going to go ahead real quick, just go ahead and take all those other pieces off for right now. Again, working clean. You can kind of see this light shading. I mean, it's somewhat helpful, but really what we need to do is that this is where we need to go in and actually change and change the classification. One of the things that I almost always do is that I go ahead and grab, a layer that I know is really going to showcase the difference across the spectrum. I have no idea why I grabbed this particular layer, but this is my go-to for this particular analysis, is to go ahead and bring it in so that I can actually start to see the yellow lines coming together with merging with some blue lines. And if I zoom in on them in space, what I'm actually seeing is you can start to pick them up and away you go. In addition to that, I think it's also important to go ahead and change up the classifications. So I know I normally say I go with as few as possible. In this case, I go the opposite direction. I want as many as possible. So I went ahead and put 9. Sometimes I'll put 15 in here just to see what shows up. Because really, I'm trying to trace all of the pathways of water through our site, right? And so one thing that might be beneficial to turn our site boundary back on. Even when I get our site boundary back on and zoom in, it's largely just showing me the stream bed. There's a few leading channels that come in from the sides, right? That's helpful information. But there's a part of me that wonders if I'm not missing something more. And so this is where, I could get crazy because it doesn't really matter what I include in here. If I go ahead and zoom, increase that number, what you're going to see is that suddenly I'm actually picking up side channels off of my side channels, right? I'm getting more detail, the more layers, or the greater number of categories that I put into this analysis. And really all that I'm after is identifying everything except for this value. Right? And this may not look like much, but as I zoom in on top of that surface, right, so that hillshade layer, and I go in and I start looking, where is water coming from? It's giving me great information. It's telling me this is exactly where the primary channel that the water is moving through, you see how it fits the landscape. It fits our model, our understanding of how water flows downhill. And even better than that, when I export this layer out into Photoshop, I can actually use stroke and other things to make this pop so that I can actually really see what's going on here. So there's a lot going on in this video, but the basic process of stormwater analysis for this particular project is relatively simple. We come in and we correct our DEM with fill. We then establish flow direction. We use flow direction to determine flow accumulation, and then we adjust our symbology until we can really understand as the maximum amount of detail that we can possibly pull out of this particular data set to tell us where is water flowing, where are the primary places that it's coming together, that it's channelizing and moving downhill. And so I'm going to go ahead and stop at this point in time. We'll go ahead and pick up with one final piece of the overall erosion study problem here.